In order to solve exponential equations, we will be using the uniqueness of b to the x. So if b is greater than 0, not equal to 1, then b to the x equals b to the y is equivalent to x equals y. And what this says is that if the bases on both sides of the equal sign are the same, then the exponents must also be the same in order to have the same value for each side of the equal sign. You would agree that if 3 to the second power equals 3 to the x, then x must be 2 for both expressions to be of equivalent value. So that's what we're going to use to solve these equations. For example A, 5 to the x equals 125. So on the left side, we have a base 5. We want to see if we can get a base 5 on the right side. So 125 is 5 to what power? And that would be the third power, right? 5 to the third power is 125. So now that we have the same base on both sides of the equal sign, we're going to go ahead and set the exponents equal. X equals 3. And that's the solution. 5 to the third equals 125. For example, b, 4 to the x equals 8. So on the left side, we have a base 4. Can we get a base 4 on the right side? 4 to some power is 8. Is that 4 squared? Nope, that's 16. So we can't get this into base 4. Let's erase that. Can we get a smaller base? Is 4 a smaller base raised to an exponent? Is there an equivalent expression for that? So how about 2? Can I write 4 as 2 to some power? Yeah, 4 is 2 squared, right? So instead of 4, I'll put 2 squared to the x. And then on the right side, I need to get a base 2 as well. So 2 to what power is 8? That would be the third power. So let me simplify the left side. This is a power rule, 2 to the 2 times x. And now that I have the same base, I'm going to set the exponents equal. 2x equals 3. I need to solve for x, so I'll divide 2 from both sides so that x is 3 halves. And that's what x needs to be to make this equation true. If I were to go ahead and check that 4 to the 3 halves power equals 8, then the square root of 4 is 2. So 2 to the third is 8. That's true. For C, 9 to the x minus 1 equals 27 to the x. Can I write 27 as a base 9? 9 squared is 18. 9 to the third is... 9 squared is 81. So that's already too big. Well, let's take that off. We are not going to be able to use a base 9. So let's see if we can write 9 as a smaller base. Can 9 be written as another base? Like 3 squared is 9, right? So let me write 3 squared instead. And then 27 can be written as 3 to what power? Well, if you take the cubed root, that's 3. So 3 to the third is 27. So that means we've got some power rules to do here. 2 times x minus 1 and 3 times x. But now we have the same base. So we can go ahead and set those exponents equal to each other. 2 times x minus 1 equals 3x. I need to distribute to remove the parentheses. So 2 times x is 2x, and 2 times negative 1 is negative 2. And then I want my x terms to be on the same side, so I'm going to opposite the 2x from both sides. Then on the left, I have negative 2. On the right, I have x. So x should be a negative 2 to make this equation true. 9 to the negative 2 minus 1 should equal 27 to the negative 2 power. So 9 to the negative 3 equals 1 over 27 squared. Is 9 cubed equal to 27 squared? Yep, that would be 729. So 1 over 729 is 1 over 729. Yep, that's true. So we verified that that is the solution to this equation.